in this video we're going to talk about mass percent composition, and we'll look at a couple examples. So the idea of mass percent is pretty straightforward. If I have a compound and I want to know the mass percentage of an element, that's equal to the mass percent of that element is equal to the mass of that element divided by the total mass of that compound. And then to turn it into a percent, instead of a decimal, we multiply it by 100. And so we can get the mass percent of an element in a compound through the formula of the compound. In which case we'll just use either the formula mass or the molar mass of the compound, or we can also oftentimes get this from experimental analyses. Mass spectroscopy and atomic emission spectroscopy are two techniques that often tell us the mass percent composition of the various elements that make up that compound. So I think it'll probably make more sense if we look at some examples. Alright, so in the first example, we want to determine the mass percent of chlorine in C2Cl4F2. And so we can do this by using the formula and the molar mass of the compound. Right? If we determine the molar mass of the compound, then we'll know how much 1 mole of that compound weighs. Well, if we have 1 mole of the compound, we'll have 4 moles of chlorine atoms. So to find the mass percent of chlorine, all we have to do is add up the masses of the chlorines if I'd had 1 mole. So I'll do 4 times the molar mass of a chlorine atom, and then divide that by the molar mass of the whole compound, multiply by 100, and that'll give me the mass percent of chlorine in this compound. So to kind of write that out, Alright, and when we determine the mass of the chlorine, we have to take into account the fact that there's 4 chlorines when I have 1 mole or 1 molecule of this compound. So for the mass of Cl, I'm going to use moles, so I'm going to use the molar mass. So if we have 1 mole of the compound, we'll have 4 moles of chlorine. So 4 moles times 35.45 grams per mole. If I have 1 mole of the compound, I'll have 141.80 grams of chlorine. Right, and then the total mass then is just going to be the molar mass of the whole compound. So I just need to add up 2 carbons, 4 chlorines, and 2 fluorines. So 2 carbons, 4 chlorines, and 2 fluorines. And so I get the molar mass would be 203.82 grams per mole, but we're assuming we have 1 mole, so we would have 203.82 grams. So then the mass percent of chlorine is then just the mass of chlorine divided by the total mass and I get 69.57%. Alright, here's another example. So I want to find the mass of table salt containing 2.4 grams of sodium. So we're talking about sodium here. So the mass percent of sodium is going to be the mass percent of sodium is going to involve the mass of sodium and then the total mass, which is the mass of sodium chloride, and of course times 100 for the percentage. So this is what I'm looking for, right? They said find the mass of table salt. So I'm looking for the total mass of sodium chloride, right? And they've given me the mass of sodium, so the numerator here is 2.4. They didn't tell me the mass percent of sodium, but I can find that, right? We did that in the last problem where we found the mass percent of chlorine using the formula of that compound. We can do the same thing here. So using the formula of NaCl, I can find the mass percent of sodium. And so then I can plug that mass percentage in here. I know I'm working with 2.4 grams of sodium, and so then it's just a matter of solving for the mass of NaCl. So using the formula of NaCl, I'm going to find the mass percent of sodium in this compound. And so that's going to be, well, let's go ahead. We've already written that formula, so I'm just going to write out, right, if I look at the formula is NaCl, I go to the periodic table, and sodium has a molar mass of 22.99. The total mass of the compound is 1 sodium, 1 chlorine. And so when I divide that out, I find that sodium chloride is 39.34% sodium by mass. All right, so now I found the mass percent of sodium. That's 39.34. They told me how much sodium, 2.4 grams, and so I'm just solving now for the mass of NaCl. So I'll just take the values I know, and I'm going to plug it in here to this formula. And we could do the algebra first, but since we don't have really convenient variables, I don't want to write out mass percent of Na all the time. And so I'm just going to go ahead and put in my numbers. I'm going to put in X for the mass of NaCl. So the mass percent of sodium, 39.34. They told us the sodium is 2.4. I'm looking for the total mass of NaCl times 100. Right, so now I just have to solve for X. So I'll divide both sides by 100. So the 100 cancels out on the right. On the left, I'm left with 0.3934. All right, I want to get that X out of the denominator, so I'll multiply both sides by X. Then divide both sides by 0.3934. So when I do that, I get to two significant figures, 6.1 grams of NaCl. All right, and that's it for this video, but if you want to see another example, I have another example on YouTube for a mass percentage type problem.